In this lesson, we will be looking at a piecewise function. The 2011 income tax schedule is given in the table below. And this tax table actually represents a piecewise function. It's a function of 6 pieces. Each line represents a piece of the function. For instance, if you made an income somewhere between $0 up to and including $8,500, then you owe 10% tax on that. If you had an income over $8,500 up to and including $34,500, then your tax is actually $850 plus 15% of whatever you made over that $8,500. And it continues, so each row in this table fills in another piece of the tax formula. Now this table is used if you're going to file with single status, but there's similar tables, similar schedules when you file with any other type of status. Now we're not so concerned with looking at such a large piecewise function, so let's just maybe take a couple pieces out of this and look at it for an example. So for an annual income earned in 2011 that is somewhere between $34,500 and $174,400, the federal income tax when filing single can be determined by this piecewise function. So capital T of X, so that's the tax that you owed for capital T, and X is your income. We have two pieces. One says the value of your tax will be 0.25x minus 3,875. Now we only use this piece whenever x is greater than 34,500 or less than or equal to 83,600. And you might want to go back to the a couple of minutes to look at that schedule and see where does this inequality come from. The second piece of the function says that the tax will be 0.28 times x minus 6,383. But again, this is only going to be used, this part of the function will only be used if x is greater than 83,600 or less than or equal to 174,400. And again, remember that the schedule itself had 6 pieces. This is just 2 pieces of that table, and we could come up with similar expressions for the other 4 pieces. So how can we use this piecewise function? Well, suppose we want to find the income tax for someone who had an income of $50,000. How can we use our function to do that? Well, the first thing we need to do is look at this $50,000 and see which of these inequalities it fits. 34,500 is less than 50,000, and that 50,000 is less than or equal to 83,600. Okay, so that's checking the first inequality. This 50,000 fits within the 2 inequalities, so that's the piece of the function we use. And if you look at it, this 50,000 does not fit into the second inequality. 50,000 is not between 83,600 and 174,400, so it has to be the first piece. So that means T of 50, it's actually 50,000, will equal 0.25 times 50,000 minus 3,875. If we plug that into our calculator, we'll get 8,625. So a person who made $50,000 and is filing their tax with a single status would owe $8,625 in tax. Well, what if instead we wanted to find the income tax for someone who made $90,000? And if we look at our inequalities, $90,000 does not fit into this first set of inequalities. It will instead fit into the second step. So again, 83,600 is less than 90,000, and 90,000 is less than or equal to 174,400. So since this 90,000 satisfies both of those inequalities at the same time, that's the part of the function we'll use. So now this time we want t of 90,000, which will be equal to, and again we're going to use the second piece now, so 0.28, and in place of the x we're going to put 90,000, and then minus 6,383. And if we plug that into our calculator, we'll get $18,817, which is the tax due for someone who had an income of $90,000. And the last part here, let's find the income for somebody who had an income tax of $15,000. Now note the difference in this problem. We're not given the income anymore, and again the income is your x value. Instead we are given the tax, which is your t value. So this 15,000 is actually the left side of our formula, not for the x values. So what we're really trying to do is find what x value will result in the function being 15,000. In order to do this, we actually need to take that 15,000 and create an equation with each piece of the function. So our first equation will be 15,000 equals 0.25x minus 3875. That's the first equation from the first piece. And the second one will be very similar, but using the second piece. 15,000 equals 0.28x minus 6383. So we need to solve both of these equations. So x equals 75,500. If we solve the second equation in a similar fashion, we will get x is equal to 76,367 and 86 cents. Which of these are the correct answer, or are both of them, or are neither of them? Well, we have to compare the x value with the inequalities. So for the first equation, we used the first piece of the function, and we got an answer of 75,000. Does that 75,000 fit within the inequalities? Well, let's look up here. Is 75,000 between 34,500 and 83,600? Yes. So that means this is part of our answer. We have to check the second piece. And again, this time we used the second piece of the function, and we got 86,367 and 86 cents. Does that fit within the inequalities for the second piece? So is 76,376 and 86 cents, is that between 83,000 and 174,400? No. So that means this x value is not a solution to our problem. So what we found is that in order to have an income tax of 15,000, your income would have to have been $75,500.